So today is chapter 7, day 8. We're going to be talking about right triangle trigonometry and applying the trig ratios to right triangles. Before we get started, I want to review real quick the right triangle identities for sine and cosine. We already covered earlier in this chapter that sine squared of theta plus cosine squared of theta equals 1. So again, anytime you see that, just replace it with 1 because it's a lot easier to deal with than the trig ratios sine and cosine. Same thing for the second one, which is sine of theta over cosine theta. That equals tangent of theta. So depending on whether you're condensing or expanding or proving or finding a ratio, that can be helpful. And then over here, this is what we're really talking about today, mostly is the sine of 90 minus theta is equal to the cosine of theta. And then cosine of 90 minus theta equals sine of theta. So basically what this means is, think about it, if you have a right triangle, then if the cosine of theta is a value, then its complement, which has to be the other angle inside the triangle, the sine of that angle is equal to the cosine of theta. And we're going to prove why this is true in example number 1 real quick. If we take a look at it, you notice they give you theta and beta. So let's go ahead and label this. You guys know from algebra 1 and again from algebra 2 that sine of theta is equal to the opposite over the hypotenuse. So we can go back, let's throw in our Sohcahtoa review. You guys remember that sine of an angle is equal to the opposite side over the hypotenuse, and then cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, Sohcahtoa is always based on the angle that you're describing. So this set of trig ratios over here is based on angle theta. And that's super important because if I'm looking from angle theta's perspective, this is our opposite side. This is our hypotenuse because, again, the hypotenuse is always across from 90 degrees. It's the longest side. And then this is our adjacent side. So if we take a look at sine of theta, we know that sine of theta has to be 3 over 3 root 5 because, again, that's opposite over hypotenuse. Following your rules of simplifying and rationalizing, the 3's cancel. It's 1 over the square root of 5, and then you can rationalize it to get the square root of 5 over 5. Now for cosecant, we know that it's the reciprocal because cosecant is the reciprocal of sine. So if it was 1 over root 5, right, if I canceled these, it was 1 over root 5, then the reciprocal would just be root 5 over 1. So that's our sine and cosecant ratio, again, from the perspective of theta. But we want to show that if we're talking about, let's say we said sine of theta, that cosine of beta, which is the complement, right? Because if I have 180 degrees here, this has to be the complement, that cosine of beta is equal to the sine of theta. That's what the property, the identity, is proving. So let's go ahead and explain why this is. Well, if I'm looking now from the perspective of beta, my opposite side for the purple would actually be 6, which is the adjacent side for theta, and then the adjacent side, again, for beta, because I'm looking from the perspective of beta, would be 3. And the hypotenuse does not change because, again, it is across from the 90. It's the longest side of the triangle. So if we're looking at cosine of beta, we notice that cosine would be adjacent over hypotenuse, which, again, is the 3 over 3 root 5, which we already did in sine of theta, becomes root 5 over 5. And then, again, because secant of beta is the reciprocal, it's just root 5 over 1. So this right here is just showing that if you know sine of theta in a right triangle, it is equal to cosine of beta because their angles are complementary, and you see how that relationship of those sides are connected. So then if I want to find sine of beta, let's just say I find cosine of theta. Let's go back again. We're looking at the blue ones because we're looking at the perspective of theta. Cosine of theta would be adjacent over hypotenuse. So we can go ahead and do 6 over 3 root 5. which when you rationalize is 2 root 5 over 5. Do the reciprocal for secant, you get root 5 over 2. And again, the reason we have these properties and the reason we're teaching you this is because now we automatically know what sine of beta is, because again, it's the complement, so it has to match, meaning it's 2 root 5 over 5, and it's root 5 over 2. So these two are equal. Let's use green. These two are equal, and these two are equal, because again, they are the complements. They're the opposite trig ratios of the complements. Cotangent doesn't really have that property. Cotangent is actually just the reciprocal for the two ratios. So if we take a look at tangent of theta, let's go ahead and do this. So tangent of theta, remember, is opposite over adjacent. So that would be 3 over 6. So tangent of theta would be 3 over 6, which is 1/2, which means cotangent is 2 over 1. And then tangent of beta, looking at purple now, would be 6 over 3, which is 2, and then the reciprocal would be 1 over 2. So if you notice the relationship for tangents of complementary angles, you notice that the tangent of theta, which is 1/2, is the reciprocal of tangent of beta. And then cotangent of theta would be the reciprocal of the cotangent of beta. So I guess if you want to set things that are equal, you would notice that tangent of theta equals cotangent of beta, and then likewise for the cotangent of theta and tangent of beta. So it's a little bit about the relationships, and those are good identities to know because they will help you simplify things. Looking down now to example 2, it says suppose a right triangle ABC has angle C. First thing you want to do automatically, if they don't give you a diagram, draw it. It says angle C is 90 degrees. Angle A and B, it doesn't matter which one they are as long as your sides and angles are labeled correctly, the ones that they give you. They're telling you AC is 3 and BC is 2. So this one's just coming up with it on your own. So again, in order to do all of the trig ratios, we need to know that third side of a triangle. And back from Algebra 1, we know Pythagorean Theorem is exactly what we can do to get there. So we have A squared. Remember, A is the opposite side of angle A. B squared is the opposite side of angle B. And C squared is the hypotenuse. So we have 2 squared plus 3 squared equals C squared. 4 plus 9 equals C squared. So C equals the square root of 13. Once we find that third side, now we can just go ahead and identify these trig ratios. Again, it's super important that you don't just assume that you're talking about the same angle, because if you notice the first part A, we're talking about cosine, sine, and tangent of angle A. So that would be cosine is adjacent over the hypotenuse. So we have 3 over the square root of 13, which is 3 root 13 over 13. Sine would be that opposite over the hypotenuse, so 2 over square root of 13, which is 2 root 13 over 13. And tangent, which again is opposite over adjacent, so it's 2 over 3. Again, going back to just some Algebra 1 and Algebra 2. But, again, it's super important that you recognize that here we are talking about different angles. We're talking about secant of B, cosecant of B, and cotangent of B. So don't just assume you're talking about the same angle and taking the reciprocal, but rather remember that secant of B is actually the reciprocal of sine of A, right? Because if we talked again about up here, we know that cosine of B, I'm just using this example up here, cosine of B is equal to the sine of A, or sine of theta. So if secant of B is equal to the sine of A, we could say cosine of B equals 2 root 13 over 13, because we know that's equal. Then this reciprocal would just be root 13 over 2. And you can do that by taking the reciprocal. That would mean that it's 13 over 2 root 13, and then rationalize it, and the 13s would cancel. Likewise, we know that cosine of A is equal to the sine of B. So we have that one, which I guess let's just leave it unrationalized because that makes it easier. So sine of B is 3 over root 13, and we can do that over here. We can say that that's equal to 2 over root 13 because we're going to flip it anyway. So now if that's the case, then this is just root 13 over 3. So again, rather than going through the whole process of rewriting the adjacent opposite and whatnot, we can use that relationship of complementary angles to find that out. And then we already talked about the tangent of A is actually equal to the cotangent of B. So that actually works out really nicely. And you know that it's 2/3. The last thing we're going to talk about here today is noticing when the verifying and the evaluating are coming together to verify or prove that the equation is actually equal. So what we're going to look at here is knowing the unit circle. You're going to have the unit circle because a lot of our stuff is open notes right now, but again, when we were in person, we didn't have a lot of open notes stuff. We didn't actually have any open notes stuff, so we actually made you guys memorize the unit circle because it is so important for calculus. You need to know that the cosine of 60 degrees is equal to 1/2, right? If I'm talking about the special triangle 60 degrees, that's adjacent over the hypotenuse, and you know on the unit circle that the x value at 60 degrees is 1/2. So you need to know that off the top of your head. It'll make things a lot easier, and it will give you more time. Know the unit circle, know the x values and y values, the coordinates, because cosine is the x value at 60 degrees, and it's 1/2. If we're talking about cosine of 30 degrees, so cosine squared of 30 degrees, we know that the x value at 30 degrees is root 3 over 2, and we're squaring it. We know that the sine value, the y value at 30 degrees is actually 1/2. So sine of 30 degrees squared is 1/2 squared, and then we are just verifying this. So if we go through it, leave the left side alone. The right side, when you distribute that exponent or you multiply it by itself twice, you get 3 over 4 minus 1 over 4. So this just proves 1/2 equals 2 over 4. 1/2 equals 1/2. Because you are verifying, you need to show every single step that you are proving. You can't just say this, jump to this. Don't do that. You got to make sure you're proving and demonstrating that knowledge to verify that they are true. Okay. We got a couple side steps there. Evaluate the numerical value. So that's just telling me what the actual value is of cosine of 60, cosine of 30, and sine of 30. Simplify it and then solve the equation. So we take a look at this one. The further we go along in this semester, you're going to notice more and more radians measurements. So sine squared of pi over 6, well, pi over 6 is 30 degrees. So the y value at 30 degrees is 1/2. The y value at pi over 4, which is 45 degrees, is root 2 over 2. And then the y value, because again it's sine, at pi over 3, which is 60 degrees, would be root 3 over 2. So again, leave the right side alone. Let's just go ahead and evaluate the left side. 1 over 4 plus 2 over 4 plus 3 over 4. You would get 6 over 4, and then reduce it, and you get 3/2. I cannot stress enough how important it is, again, that you know the unit circle, and the more you deal with it, you're knowing it and you're memorizing it, and you understand the values and which quadrant you're in, and not just looking at the unit circle and finding the x or y value off of it, okay? So that's day 8. If you have any questions, feel free to ask your teacher, but go ahead and try the homework. Good luck.